Hey students, welcome to the channel Learn Smarter and Remember Longer. Let's start our class with a small riddle today. It can fill a room without occupying space. What is that? So you can pause your video and can find it out that what it is talking about. It is actually light. Okay, so over here we can see few pictures, right? That is, one is of rainbow, right? Another one is of chair, right? Another one is of green leaf. Okay, now how do we see these various objects, right? What help us in seeing this rainbow that is of different color, this chair, this again of different shape and color, again this green leaf. So many of you might be thinking that it's eyes, right? But is it so? If you can you see an object when it is placed in a dark room? Can you see, just think it about it. So it is not true because we can only see an object if the light from the object comes to our eyes. That is, whenever the light comes to our eyes, then only we can see an object. So for that reason, it becomes impossible for us to see an object in a very dark room or in a very dark area, right? So there is two possibility that the light might be emitted by the object. You can see it's because of the bulb, right? You can see that bulb is emitting light by itself, so the light might be emitted by the object. Okay, another probability is that the light may be reflected by the object. Okay, so you can see that the sun, from the sun the rays are coming to the apple that is red, and that red color is being reflected in our eyes, so that's why we see a red color apple. Okay, okay, over here we can see that it's a mirror. Suppose let's consider that it's a mirror. Now we can see a light is being incident on a mirror. Now how will this light be traveling after this? Let's see that. So we can see that the light after falling on the mirror is being reflected away, right? Light which strikes at any surface is said to be the incident ray, and the light that comes back from the surface after reflection is known as the reflected ray. Okay, suppose we are drawing a normal. Okay, so this normal is being drawn from the point of incidence, that is where the light ray strikes the surface, and from the same point, that is from where the light is being reflected. So it is being drawn. Okay, what is it? It is said to be a normal. Why? Because it is making an angle 90 degree to the line representing the mirror at the point where the incident ray strikes. So whenever an incident ray strikes at the mirror, you can see that the angle between the mirror and the normal is 90 degree. Okay, so this line is said to be the normal. Okay, normal to the reflecting surface at that point. So the reflecting surface over here is what? It is a mirror, right? Now we can see that the angle of incidence is being formed. What is that? That is when an incident ray is being struck on a mirror and there is a normal to it. So the angle formed between the incidence angle of incidence, I mean the incidence ray and the normal is the angle of incidence, right? Now we can also see another angle is formed, right? That is when the that is when the ray is being reflected. Okay, and the angle is formed between the reflected ray and the normal, that is said to be the angle of reflection, right? So what we learned about in this slide is that when a light is striking at the mirror, okay, it is being reflected. Okay, Now this ray of light which is being striking at the mirror is said to be the ray of incidence or an incident ray, and the ray which is being reflected away is said to be the reflected ray. Now if we consider a normal which is formed is actually 90° to the surface, reflecting surface, that is the mirror, then we can find an angle is formed. We can see that an angle is formed, that is with the help of the incident ray and the normal, there is an angle which is said to be the angle of incidence. Okay, and when the right ray is reflected away, there is again another angle is formed which is said to be the angle of reflection, right? Now the angle of incidence is equal to the angle of reflection, and this is the first law. It is very much clear from the diagram that the angle which is being formed is always equal to the angle of reflection, and hence this is said to be the first law of reflection. And what is the second law? Let's see that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane, right? All lie in the same plane. So we can see that this is actually the point of incidence, okay? That is the incident ray, which is where it is striking the mirror, is the point of incidence. And from where it is reflected, it is also as called as the point of reflection. So both of them are same, okay? And what is being observed, it is always observed that an angle of incidence is always equal to the angle of reflection, which is actually the first law of reflection. And the incident ray, the reflected ray at the point of incidence, and the normal all lie at the same plane, right? If I consider this mirror as the same plane, therefore the incidence ray, the normal, the reflected ray all are lying on the same plane, right? And this is another law of reflection. So we come across two laws, right? First is that the angle of incidence is equal to the angle of reflection, and another one is that the incident ray, the normal at the point of incidence, and the reflected ray all are lying on the same plane. Now we can see, what is this? The question is that we can see that it's a mirror, right? It looks like a mirror. Okay, let's see who's here. Okay, so we can see that Shefali is here. So Shefali is very happy, you can see, right? So she has come near the mirror. So what is the probable thing which she can see on the mirror? Her reflection, right? Now, what this reflection is said to be? What is this actually said? It is said to be a lateral inversion. Now, what is lateral inversion? An image formed by a mirror, that is the left of the image in the left of the object appears to be right in the image, and the right of the object appears to be left in the image, right? You can see that its right hand is becoming left hand in the image, and its left hand is becoming right hand in the mirror. So this is known as a lateral inversion. Now we can see over here two surfaces, okay? One is this, that is a very uneven surface, and it's a very even surface, right? Now we will see two scenarios, that if a light ray falls under, on this uneven surface, what will happen? And if the light ray falls in the plane surface, right, in a total even surface, and what will happen? Let's see that. So the light ray, yes, it is being shown that it is an angular, the incident ray is has been fallen on this uneven surface, right? Now let's see how these rays are reflected. See, they are reflected in a very anonymous way, right? That is, there is no particular way they are reflecting. They are reflecting in different ways, right? So what we can see that when all the parallel rays reflected from a rough or irregular surface, those reflected ray are never parallel. Why? Because of course the surface is very uneven. Okay, so whenever it is coming and it is falling on a uneven surface, it is reflected in a very, like, in their own direction to form a equal angle of incidence and reflection. So we can say that whenever parallel rays of light is falling on an uneven surface, it is being reflected in a very irregular and uneven manner. Okay, now same is happening for the plane surface or the even surface. So the angle of the incident rays falling on it, let's see how the rays are reflected. They are reflected in a parallel way, and it is called a regular reflection. If on a irregular surface the light rays, that is a parallel rays of light, are falling, that means it is being reflected in an irregular reflection. And if it is falling on a plane surface, on an even surface, then it is reflected on a parallel ray. Okay, and it is said to be a regular reflection. Now there is something to remember, right? That is, the diffuse reflection is not due to the failure of the laws of reflection, right? So we can see that this irregular reflection is actually uh, not because the lights are not following the laws of reflection. It is very much following the laws of reflection, but it is because the surface is uneven. That is what is being shown over here, right? That is what is shown over here. Okay, that because of this only it is being uh, showing this diffuse reflection, but actually it is not so, and it is totally following any kind of laws of reflection. Okay, let's move ahead. Thank you.